Hello, hello. My name is Brian Ruiz, and today I'll be going over logic gates and how they function. I'll be going over the AND, OR, and NOT gate. The AND gate mainly functions off two transistors, and the inputs on the transistors have to be the same. So if the input is, for example, in the binary form of 0 on both of them, then the LED light will turn on, and the same would be vice versa. If the input is an input of 1 in binary form on both transistors, then the LED light will turn on. And for the OR gate, you still require two transistors, but it has to be, the inputs have to be different. So for example, we have transistor A and the input is 1, and then we have transistor B and the input is 0, the LED light will turn on. The same would be vice versa, but if both transistors are at 0, the LED light won't turn on. And finally, for the NOT gate, the truth table states that it's actually just one transistor, and the truth table states that if the input is 0, then it would be inverted. It has to be in parallel with the LED light. So if the input is 0, the output would be 1, and that current would go towards the LED light, and the same would be vice versa. So here we have the beginning of the OR gate. You'll see the resistor going from the positive towards the first gate on the transistor, and we have the transistors and the LED light placed as such. So pretty much all we have to do is put them in series or in parallel depending on what we're doing, and we're going to use the jumper cables to do so. So we'll put this blue cable from the first post on the transistor A to the middle post on transistor A, and then we'll put the red one from first post to first post. And finally, we have an extra one. We have last post on transistor B to the last post on transistor A. And now finally, we have from middle post to first post. And then we can go ahead and connect our Elegoo Uno Arduino here. We have the 5 volts, actually we have the ground going to negative, and the 5 volts in. And you can see here that the LED light will turn on. So now if we just remove this post here, this is the example of the OR gate, as the input here would be 1 on transistor A and an input of 0 in transistor B. So we still see the outflow into the LED light. Here I'll be demonstrating the AND gate. As you can see, once again, the resistor is on the 5 volt that it'll be receiving from the Arduino here, and then it goes to the first post of transistor A. And then you have the first post and last post of both transistors together, and then you have the LED light at the very end. Here we'll just be connecting the jumper cables once again to get a better understanding of how you put them in either parallel or series to see how the LED turns on. So here we'll have this blue jumper cable go from the first post to the middle post. And then we'll have this green one, first post to middle post on transistor B. And then I'll just have this red one go from the LED light towards the ground, and then once again the LED light towards the last post on transistor B. Here it is, as you can see. Now all we have to do is connect it to the ground first, and then and here you'll see the LED light turn on. Now if we were to disconnect one of these, we'd see that the LED light turns off, and that's because in an AND gate we have to have both of the inputs be equal. That is, whether it's 1 or a 0 in binary form. And finally, we have the NOT gate, which only requires one transistor. Here you can see, as always, the resistor goes from the positive to the first post of the transistor, and I have the LED light all the way over here. And we'll be connecting these with, obviously, the wires. So first we'll have the longest wire here. We get it from the first post of the transistor, and we have it going here to the LED light, and then we'll have the second post of the LED light go towards the ground, and just finally we have the last post go to ground. And then we'll connect these ground first, and we have the LED light turn on. This makes the LED light and the transistor be in parallel. So here we are basically receiving a 0 in the transistor, and since it's the inverse, it'll basically be closed and the current will be going towards the LED light. And if we have this, then it'll just be a 1 on the transistor, current going through the transistor, but not the LED light.